2-minute anaesthesia in critical care, osmosis. The topic of osmosis has multiple key definitions and thus is easily examinable. Key definitions are the following. 1 mole, 6 times 10 to the 23 units of a substance, also known as Avogadro's constant, whilst 1 osmole is 1 mole of any fully dissociated substance dissolved in a solution. What's the difference between a solute and a solvent? A solute is a substance being absorbed into a solution or dissolving medium, also known as a solvent. Osmolarity is the number of particles per litre of a solvent, whilst osmolality is the number of particles per kilogram of a solvent. This is temperature independent. Plasma osmolality is 2 times sodium plus potassium plus glucose and urea. Osmosis. So a solvent moves across a semi-permeable membrane from a solution of a low concentration to that of a high concentration in order to equalise the solid concentrations on both sides. Osmotic pressure is the pressure caused by the difference in the amount of solids between the two solutions separated by a semi-permeable membrane. Essentially, the osmotic pressure is the pressure needed to stop the flow of fluid through the semi-permeable membrane via osmosis. Reverse osmosis. So if you apply a pressure to a hydrostatic solution to overcome the osmotic pressure, this will favour a shift in the movement of fluid from the hypertonic solution into the hypotonic solution through the semi-permeable membrane. Renal replacement therapy is a real-life example of the use of osmosis for both peritoneal and hemodialysis, while CVVH requires high hydrostatic pressure. Hemodialysis allows the removal of small solutes by diffusion and osmosis between the blood and dialysis until toxic waste products are cleared, i.e. urea and potassium. A countercurrent system improves the efficacy and efficiency of this system, whereby the blood and dialysis move in different directions. Colligative properties. These are the properties of a solution that depend on the ratio of the number of solute particles to the number of solvent particles in the solution, rather than the type of molecule present. So both the boiling point and osmotic pressure increase in proportion to the molar concentration of the solutes, whilst both the freezing point and vapor pressure both reduce in proportion to the molar concentration of the solute present. This table shows the 4 alterations in the physical properties that occur due to the presence of solute within a solution. So change in mole of solute per kilogram of solvent. Both the boiling point and osmotic pressure increase by this amount, and the freezing and vapor pressures also decrease by the corresponding amounts. First of all, we will discuss saturated vapor pressure. This is the pressure above a liquid in a sealed container. At equilibrium, the number of particles leaving the liquid is equal to the number of particles returning back to the liquid. So if we add a solute, for example sugar, to the solvent, there's less solvent molecules on the surface, and this will lead to less solvent molecules being released into the vapor phase. Raoult's law states the addition of a solute to a solvent reduces the vapor pressure of the solvent in proportion to the molar concentration of the solute. The definition for tonicity is similar to that of osmolality, but not the same. Tonicity compares the relative solid concentrations of two solutions separated by a semi-permeable membrane. But unlike osmolality, which is determined by the total number of solid particles, tonicity is only influenced by solid particles which do not cross the membrane, and thus is classified into 3 groups: hypertonicity, isotonicity, hypotonicity. This is important for the key understanding of both cellular fluid, intra and extracellular fluid, and general fluid administration. Now we compare red blood cells in 3 different bathing mediums. An isotonic environment, red blood cells remain the same shape and size, as water moves into the red cell and also diffuses out of the red cell across the semi-permeable membrane. Hypotonic environment, red blood cell takes up water and swells, and there's a risk of hemolysis. And finally, a hypertonic plasma concentration. This causes water to move out of the cell, leading to dehydration and shrinkage of the red blood cell. Another clinical example of osmosis in action is use of mannitol. Mannitol is an unmetabolized sugar given intravenously, which is freely filtered by the renal glomerulus with no active reabsorption. This therefore increases the osmolarity of the glomerular filtrate, resulting in reduced water absorption and increased free water loss. This increase in plasma osmolarity leads to an increased movement of water out of cerebral cells into the plasma and thus reduces intracranial pressure. An osmometer is a device used in laboratories to measure the concentration of particles in a solution. They can be expressed as both osmolality and osmolarity. A common mechanism by which this is achieved is the freezing point depression. This relies on the principle of the relationship between number of moles of a dissolved solute in a solution and the change in freezing point. So the sample is cooled in the cooling chamber to below freezing point. This is achieved by the Peltier effect, which is the reverse of the Seebeck effect. A needle is then inserted into the sample to allow crystallization to form, thus increasing the temperature to freezing point. This produces the freezing curve, and the osmolarity can be calculated via specific calculations. Please like and subscribe. The last topic we'll discuss is solubility, and this is a measure of how easy a solute can be dissolved into a solvent. This is affected by the nature of the solvent, the temperature and the pressure, which involves Henry's law. Henry's law states that when a gaseous mixture is in contact with a solution, the amount of any gas which can be dissolved into the solution is proportional to the partial pressure of the gas. i.e., you double the partial pressure, you double the concentration dissolved in the liquid, i.e. molar fraction.